Hello and welcome to the beautiful Western Cape. I've made just a short video today to show you how to navigate using the sun and how to build a field compass by magnetizing a needle with your knife in order to determine direction. We have become very dependent on technology in order to help us to determine direction. When we're lost, we tend to just check our phones for a GPS signal. We ask Google Maps to show us the way. But we don't always have technology with us. Sometimes you don't have cell phone reception when you're out in the mountains or in the wilderness, or you might have lost your compass. If you need to determine direction and you don't have a compass or you don't have a GPS, there are two ways in which you can use the sun to make a compass for yourself. The first way is by using a stick in the ground method. It's quite a simple method, but of course you do need the sun to be shining because you're going to use the shadow to determine direction. So basically you just put it in the ground, and then because shadows move from west to east, you can determine by the movement of the shadows what is north and south. So all you want to do is you want to put it in the ground and you want to mark the tip of the shadow. It's really important to mark the tip of the shadow, so don't use an enormously long stick because then your shadow is going to travel really far. The reason why is because when the sun is moving in a linear direction, your shadow is going to move in a linear direction and you're not going to get necessarily two different points on the ground, and you might make a mistake in your navigation that way. So put it in the ground and just mark the tip of the shadow with a little stone or something like that. Give it about 15 minutes time and then mark the next point of the shadow. And then what you can do is you just bisect your two markers, and that will give you a rough east-west line. From your east-west line you can determine north and south. Now it's important to note at midday in the Southern Hemisphere shadows tend to point towards the south, and in the Northern Hemisphere at midday shadows tend to point towards the north. So if you need to have a quick look at which direction you have to move into and you don't have the time to wait for a shadow to move, you can use that at more or less midday. Right, so I'm going to place a stick in the ground and I'm going to mark it. I'm going to point the camera towards it just now, and then I'll show you all of the methods that I'm using here. But to get us started, I've just marked the point of the shadow. I'm going to show it to you in a minute. The other method that you can use to determine direction by looking at the sun is with an analog watch. So in the Southern Hemisphere you point the 12 o'clock of your watch at the sun, and halfway between the 12 o'clock mark and the hour hand on your watch is going to give you a north-south line. Now it's important not to make the mistake of thinking that gives you north. It gives you a north-south line, so you still need to determine which is north and which is south. Couple ways you can do that is by using the prevailing wind. If you know that the wind direction, like today we've got a westerly wind here, if you know that you've got a westerly wind, then you can determine which side west will be, and that will give you north and south. So to demonstrate to you, the sun is over there. It is currently 5 o'clock. So halfway between the sun and 5 o'clock, my 5 o'clock, is going to give us a north-south line. So that is approximately between 2 and 3, 2 o'clock-ish. So we're going to look at that way. So north is either that way or that way. Now I just have to determine which is north and which is south, and that will give me a bit of direction. Last, and as promised, I'm going to magnetize a needle using my knife to make a compass needle that I'm going to float on a leaf in a bit of water, what we call a field compass. Now, I'm going to use the cup from my canteen cup combination. I know that it's not going to interfere with my needle or with the magnetic properties of my compass because I have checked it with another compass. It's got no interference, but you should be careful when doing that to make sure, because not every container is going to have no effect on your compass. So check it first with something else before you do that. Otherwise, if you've got no container in which to float your needle, you can dig a hole in the ground, and if you line it with a plastic packet, you can fill that with water and you can float your compass on that. Having said that, be very careful that you don't have something on you like a knife, a belt buckle, electronic devices that are close by your compass needle that's going to give you a bit of interference, and it might point you in the wrong direction at the end of the day. So just be careful what you have nearby. And then yeah, here goes. So I find that if you use a slightly larger needle or a slightly thicker needle, you get a better compass needle. It's a slightly stronger magnet once you've magnetized it. I know there are some non-believers when it comes to this. A lot of people have struggled to magnetize a needle before to make a compass needle. You can actually use more than just a needle. You can use a blade, any razor blades or surgical blades that you keep in your medical kit. You can use a hairpin. I've magnetized a hairpin before. I just scrape off the coating from it and then magnetize it as I would usually magnetize a needle. So what I'm going to do is I'm just going to scrape along the one side, meaning this side of the needle, and I'm going to magnetize the thicker part here, and that will give me two opposite poles in the needle. You can use a battery to do this as well. If you take, I've used the positive end of a battery and just gone along the needle. Obviously you have to lift it up, especially if you're using a magnet to magnetize the needle. Okay, so here goes. So you can do that about 40 times, a little bit more if you want to, depending on what you're using as well. A silk scarf will also magnetize it, but I do find you need to spend a bit more time because it gives you a bit of a weak magnet, and then it's not so certain in determining the direction. So I think this is sufficiently magnetized, and what I'm going to do is I'm just going to bring the camera a little bit closer and show you all of the compasses that I've got here now. Okay, so come along with me. So there's my needle, and then all I'm going to do, and if you can see that, I'm just going to float it in there. And I don't really want it to reach the side. And if you just give it a few seconds, you'll see it starts to reorientate itself. And then if you're unsure, what you can always do is use a knife, whatever you magnetized it with, and you'll see that definitely responds. Okay. So I just wanted to go to the middle, preferably. Just check that the wind doesn't interfere too much with it. I do find quite consistently that the side that I have magnetized usually points south. So that's the other thing about this, is if you have no other way to determine direction, there's no sun around or anything like that, and you're not sure which side of the needle is pointing north and which is south, personally I find that the side that I've scraped on usually points towards the south. But you can play with it and see for yourself what direction you get. And sometimes it can take a little while for it to orientate itself. It is being caught up a little bit by the wind. If you are unsure still, what you can do is disturb it a little bit and see if it finds the same direction again. If it reorientates itself, that will also give you a good indication that there isn't something around you that is moving around, and move away from it and come back and see what it's done. So there it is now, and what my compass says. I'm just going to try and keep them away from each other. So that looks pretty accurate to me. I'm going to disturb it one more time. What I'm waiting to see is just if it, without help, will reorientate itself in that direction. Now what I'm going to do one more time, just to show you, is with my compass we can check whether that has actually worked. And that to me looks pretty accurate. Pretty neat. Okay, so while I'm just waiting for the sun to come back out from the clouds so that we can see where the other point of the shadow line is going to be, I just wanted to show you where I put my stick and where I determined the point of the shadow would be. So I have just put these two stones over here, so that's where the tip of my shadow was before. And like you can see, if the sun is setting over there, what's going to end up happening, the shadow's point is going to head that way, and the second point is going to be right about over there, depending on where the sun is. So don't put a stone to mark the shadow halfway down the shadow, put it on the point of the shadow. Alright, we can check it just now. I think we'll get a bit more sunshine in a minute. In the meantime, what I wanted to explain was why your compass needle and your shadow line compass is going to be two slightly different norths. So the compass is always going to give us magnetic north, and the shadow method, or the stick method as some people like to call it, is going to give us geographic north. And the difference between those two will be your angle of declination. And what that basically is just the degree of variance between magnetic north and geographic north, and for every place on Earth that degree of variance is different. So in the description for this video I'll post a link where you can go and check what the angle of declination is for the specific area that you live in. Remember to check it often, it does change, so don't think that today it's 26.4 degrees and next year and the year after it will remain the same. You do have to check it every now and then and make sure that you've got the updated one. So now that I've got some sunshine again, I can place my second marker. And all I've got to do is draw a line between them, and that will give me a rough east-west line. Now remember, if you're going to determine north and south from that, you're going to get geographic north. And if you check that against a compass, you're going to see that there should be a slight difference unless your angle of declination is naught. So currently where I am, the angle of declination is 26.4 degrees at the current time. So I'm going to have to adjust for a 26.4 degree differentiation in the two angles that I've got for north. I'm just going to bring you a little closer. Okay. Magnetic north. And geographical. Well, that's all from me on navigation and making a field compass. I really hope that this has helped you. Go ahead and post any questions that you've got in the comments below. Keep watching for the next video.